Welcome to the segment of our show explaining physics that's out of this world.
Hi.
The rapid development of space technology began in 1957 during the Space Age, an era where humans had a keen interest in space exploration. There were rapid advances made in rocketry, material science, and computers, among many other fields that have contributed to the development of spaceships. One of the greatest social impacts of spaceships has been the landing of Apollo 11, considered as one of the defining moments of the 20th century. The immediate impact of spaceships and subsequently space exploration is how it shaped humanity's vision of the world. Seeing Earth from space has revolutionized their understanding of Earth as a living system, affecting their relationship to the natural world and their appreciation of the greater community of mankind. The exploration of space near the Earth has allowed humans to study their resources, provide essential information about weather, and provide means for navigation that was both life-saving and had enormous economic implications. Many of the technologies originally developed for space applications have also converted into technologies that they use daily, such as water purifiers and most notably memory foam. The development of spaceships does have a marginally negative impact on their environment due to rocket emissions, which deliver gas particles directly into the middle and upper atmosphere. They have a hefty carbon footprint due to the burning of solid rocket fuels, and rocket soot accumulates in the upper stratosphere, which likely leads to ozone loss. However, since they are relatively infrequent, spaceships launches don't have a huge impact on their climate. Spaceships are used by both government agencies such as NASA, as well as independent companies to deliver communication satellites to orbit, allowing for Earth observation, meteorology, and communication. They are also currently being used on resupply missions to deliver cargo to the International Space Station, which serves as a microgravity environment where research on human biology, astronomy, and most importantly physics are being carried out. The space station also tests spacecraft systems for missions to the Moon and Mars, which will aid humans in planetary exploration for space colonization. With space launches being increasingly commercialized, it has now become a hobby for human billionaires. SpaceX has had a large part in the research and innovation of spaceships, with its founder Elon Musk stating its ultimate goal is to put a colony of 1 million people on Mars. The company revolutionized the field of space exploration, developing the ability to launch spaceships using reusable rockets, a fundamental breakthrough in the field. Research is continuously being carried out to improve the design of spaceships in order to further our ventures into deep space. Astronauts aboard the International Space Station currently have to exercise and alter their diet to endure extended stays in microgravity, which is why research is currently being done on artificial gravity in spaceships. A lack of gravity for extended periods of time can cause motion sickness as well as bone and muscle deterioration, which is why human deep space exploration will most likely require some form of artificial gravity. The physics principle behind simulated gravity lies in the centrifugal force present in circular motion. In a spinning spacecraft, the centrifugal force will theoretically be pushing astronauts outwards, creating an effect similar to that of gravity's. The magnitude of the force would depend on two factors: its size and speed of rotation. If artificial gravity is to be successfully done, it has to be done with a very large spacecraft that spins very slowly, because if the radius of rotation was too small, the force imposed on their heads and feet would differ too much. Additionally, because of large Coriolis forces that act perpendicular to the velocity in a rotating frame of reference, the centrifugal force would be curved instead of linear, thus making things even more complicated. Although we won't have rotating habitats anytime soon, the application of simulated gravity could be used to maintain the fitness of astronauts in space in the near future.